today, 6.8, we are graphing radical functions. So, way back when we first started graphing different functions, back in chapter 2 even, we talked about translations, right? Moving right, moving left, moving up, moving down, stretch, compress, flip, all that wonderful stuff. And I said then that if you learned it then, you would be good for the rest of the year anytime we came across something of the same thing, right? Okay. So, today, if we talk about graphing a radical function, your parent function, your original function, is y equals the square root of x. When you graph this parent function, it always starts at 0, 0. And two main points we have is if I were to plug 1 in for x, the square root of 1 is 1 on the y. And if I were to plug in 4 in for x, it is 2 on the y. This is the parent function. It's this curve that starts at the origin. This is a basic radical square root function graph. Now, what we're going to do today is take this graph and we're going to move it right. We're going to move it left. We're going to move it up. We're going to move it down. We're going to stretch it. We're going to compress it. And we're going to flip it. Okay? All right. So, if I have y equals the square root of x minus h, that h tells me if I'm going to go right or left. If I have y equals the square root of x, and then outside the radical, I have plus k, the k tells me if I am going up or down. Just a minute. If I have a number in front of that radical, just like when we did absolute value functions or we did quadratic functions, if I have an a in front of that square root of x, that a, if a is greater than 1, it's a stretch. And if a is between 0 and 1, it's compressed, or it gets flatter. If a is negative, so a is less than 0, it's negative, it flips over the x-axis. This should all sound very, very familiar. Hopefully. All right, so example number 1. If all I do is ask you to graph, and I give you y equals the square root of x minus 4. On your paper, the first thing I want you to do is describe how this translates. What's happening to it? It goes to the right 4. Correct. Right 4. One of the ways we talked about how to know if it goes right or left is what's in with x, you set equal to 0 and solve. If I set x minus 4 equal to 0 and solve it, I get x equals 4. So it goes to the right 4. So then we are going to sketch a graph. We're going to take that curve we started with, remember this original curve? And we're going to move it 1, 2, 3, 4 to the left, or 4 to the right, and start it right here and do the exact same curve. That's it. I have, example number 2, I'm going to ask you to graph. If I have y equals the square root of x plus 3, how does this one translate? Up 3. Very good, Chris. Up 3. All right, so my original graph again was this one. Now I'm going to take this curve and I'm going to move it up 3. 1, 2, 3. So it starts here, and it's the same curve. That's what I'm looking for, is to see that you understand how it translated. Questions so far? We're all doing okay? All right. Example number 3. In today's homework for 8 through 12, actually we can probably go, yeah, let's start 8 through 14. Let's do that. It says to graph. And it only has one thing happening so far. So let's say I have y equals, let's go with the square root of x plus 2. How does this one translate? Left 2. Very good. Left 2. So then I'm going to sketch myself a graph. Now, I like to put the original one on. You do not have to. But if I take this original one and I move it to the left 2, it starts here and curves the same way. All I'm looking for. And if you are unsure, what do you have in front of you that you can use to double check? Your graphing calculator, by all means. You can always graph it to check it, right? Just the final one I'm okay with. I like to put the original one on just so that you guys can see where I'm comparing it, but on the homework, I just need the one that you've moved. You can put both if you want. If it helps you, that's fine. It flipped over. Exactly. Yep. Correct. All right, here's example number 4. All right, this is going to cover your 16 through 20. Again, it's going to ask you to graph. But now maybe more than one thing's going to happen. Let's say I have y equals the square roots of x. Let's go with plus 3 and then minus, maybe, minus 2. So what are the two things that are happening here, you guys? Good. Left 3, down 2. Awesome job, Chris. All right, down 2. So now here's my graph. My original one was here. Again, you don't have to draw the original. But from the origin, I'm going to go left 3, down 2. My curve is going to start right here. And I just want you to sketch my curve. How are we doing? All right. Example number 5. On example number 5, this has to do with number 22 and 24. It asks you to solve. Now, it wants you to solve by graphing. I want you to solve normal. So for these two problems, it says solve by graphing. I just want you to solve. Okay? So for example, if they give you the square roots of 3x minus 2 equals 5. If we were graphing it, what they want you to do is to graph this one, and find out where they intersect. That tells you your answer. I want you to do it algebraically. Just solve it. How do I get rid of the square root? Square both sides. Absolutely. So that means on this side, the squared and the square root cancel. So I have 3x minus 2 equals, on this side, 5 times 5 is 25. So now I add 2 to the other side. So I have 3x equals 27, and x equals 9. Okay? Are we still doing good? All right, so if you know how to translate a square root, if I show you what the parent function is for a cube root, can you translate that? I absolutely believe you can. So let's talk about a cube root. If I have a parent function of y equals the cube root of x, the parent function is what I consider a backwards s. So it kind of comes up, crosses through the origin, and goes up this way. All right. So if I can translate that, I'm going to take that same shape. I'm going to move it right. We're going to move it left. We're going to move it up. We're going to move it down. Or you can flip it, right? Okay, so here is example. Am I at 5? 6, thank you, sorry. Example 6. Time flies when you're having fun. 26 through 30. 26 through 30, I'm going to ask you to graph. And let's say I have y equals the cube root of x minus 1 plus 4. What was it, Chris? Right what? Right 1, up 4. Very good. Translation follows the same thing for everything. Yes.
The same way as cube root and square root.
Mhm. Yep.
Yeah, it's just it's not the parabola.
Correct. All right. So when we graph this one, oops. Again, remember that backwards s crossed through the origin. So now if I go to the right 1 and up 4, that backwards s is going to cross right here. So it comes through, kind of crosses, and goes up. And again, I'm just looking for a sketch to show me you understand how it translated. Okay? Do we need another one of these? You guys think you're good? We think we're good. Are you sure? Okay. As I said, if you learn the translations right the first time, we're good. Irene, you got a question? Correct. I want to see that you understood how it translated. Okay, that's the big takeaway. Okay?